Welcome, geometry students, to my little lesson on the distance formula. So we're going to learn a really important formula, and I'm going to try to show you where it comes from. So let me just underline distance formula. We'll be using this throughout the course. And I have already plotted A, which is negative 5, 1, and B, which is 5, 6. And what we're going to be doing is getting the distance of that. So how many units long is this? And one way we can do it, which you probably already know, is that we could make a right triangle out of this picture, and we could basically count the legs here, and we could use the Pythagorean theorem. So this distance is 10, I believe, and this distance is 5. There we go. So we're going to use the Pythagorean theorem. So a squared plus b squared equals c squared. And I know we've worked with that before. I'm going to use the 10 for the A, I'm going to use the 5 for the B, and this distance will be the C, so I'm going to keep that C. 10 squared is 100, 5 squared is 25, equals C squared. 125 is 125 C squared, and then of course we're going to square root each side. And this can actually be broken up into 25 times 5, so our final answer will be 5 rad 5. So that's the way that we would normally do our distance, but I'm going to show you a formula, and it's called the distance formula. And it actually comes from the Pythagorean theorem. So I'm going to get the distance of this, and one way I can do it is subtract the x values. So whatever these x values are, if I subtract them, I'm going to get the distance. And do you see how this distance is squared? I'm going to put a little squared there. The b squared, I'm going to subtract the y's. So I'm going to put my plus, subtract the y's, and it's also squared. And c squared, well, in my final answer, I don't want a c squared, I want a c. So see how I take the square root on the step above? So we're going to square root all of this. And this right here, let me circle it, is the distance formula. And let me show you that that works with these 2 points. D equals. So I'm going to use this one as the x2, this one as the x1. So big square root. 5 minus a negative 5 is really a plus 5. Right? We have a double negative. And then if I start with this x, I got to start with this y. So it's going to be 6 minus 1, all squared. So distance equals 5 plus 5 is 10 squared. 6 minus 1 is 5 squared. So underneath this radical, we have 100 plus 25, which is the square root of 125. And again, it reduces to the same thing, 5 rad 5. So let's practice. I have 2 coordinates here, and let's practice using the distance formula now that we know where it came from. It came from the Pythagorean theorem. So the first thing I like to do always is write the formula. So x2 minus x1 all squared plus y2 minus y1 all squared. That's the formula. And the more that you write that, the better you're going to become at it. I will choose this one for my x2. It doesn't matter which one you start with as long as you're consistent. So I'm going to do negative 3 minus a negative 1, which is really a positive 1. That had a double negative. I have to go back to the 4, and so I'm going to do 4 minus a negative 6, which again is a plus 6 all squared. I'm going to simplify each parentheses. Negative 2 squared is 4. See, I'm kind of doing this. See how I did that one shot? I did negative 2 in my head, and then squared is 4. You can do that. And 4 plus 6 is 10. 10 squared is 100. So the distance is rad 104. And I will simplify this because I know rad 104 is 4 times 26. So the final distance would be 2 rad 26. If your teacher or the worksheet wanted you to give a decimal, you would just put that into your calculator and give the decimal.
Yeah, we can cut that out, remember.
All right, let's try another one together. I want the distance of these 2 points, and I'm going to use the distance formula. Distance formula, big square root sign. x2 minus x1 all squared plus y2 minus y1 all squared. I think I'm going to change pens here since this looks like it's getting a little light, so let me just change to a purple pen. All right, I'm going to choose -5 as my x1, so I'm going to do -5 minus a -1 is a +1 all squared, plus, then go back, you've got to go to the 0, 0 minus 3 all squared. I'll just extend my line. And again, you can simplify this and square it. I know you guys can do that correctly, so that's no problem. So -4 squared is going to be 16. -3 when you square it is 9. And look at this, this ends up to a nice perfect square, 25. So the distance of this 2 points is 5. And we could put 5 units if we wanted to be precise. Now that we've done a couple examples together, I would like you to try this by yourself. So why don't you pause the video, and then we will, I will allow you to try the first couple steps by yourself. All right, let's see if you did the first couple steps by yourself correctly. We want the formula, x2 minus x1 all squared plus y2 minus y1 all squared. And if we put the numbers in, and again, depending which one you put, I'm going to assume you put the first one in. 8 minus 10 all squared. We've got to go back. -2 plus 5 all squared. So check your work to see if you put a plus 5 there for the double negative. If you didn't put a plus 5, then you may have to go back and correct that. All right, so why don't you pause the video now and do the next couple steps together. I hope you've had a chance to finish the next couple steps, and this is what we should have. 8 minus 10 is -2 squared, so that is 4. -2 plus 5 is 3 squared, so that is 9. And then here, 4 plus 9 is rad 13, and I'll put a U for units, and you can check to see if you got that right. So thank you for joining me, and I'm hoping tomorrow you will be able to tell me what this formula is and where it came from, and we will be able to practice in class together. Thank you, and see you tomorrow.